Beyond visual line of sight is a big deal for electrical utility companies. The cost of performing UAS electrical grid inspections will drop dramatically once the drone inspection industry is allowed to fly missions beyond the visual range of the system operators. BVLOS flights are normally flown autonomously under computer control while the pilot monitors an HD video feed. When flying BVLOS missions, communications between the ground crew and the aircraft are critical. In this case, the professional UAS uses two standard point-to-point radio control links, as well as a 4x4 cellular LTE communication link, allowing full operational control of the drone from hundreds of miles away. It costs roughly the same to operate a drone to take only a few photos as it does to fly a system that can capture a range of data simultaneously. This payload is one of the world's most advanced, a multi-sensor system with 6 integrated cameras and scanners. It incorporates HD video, a high-density LiDAR scanner, oblique and nadir still cameras, a thermal infrared camera, and an ultraviolet imager. This means several different inspection requirements can be satisfied in one flight. Almost every department in a typical utility T&D company can put drones to work today to begin to improve outcomes from ongoing vegetation management, maintenance, and engineering work. Purpose-built software tools help to simplify inspection fieldwork. Here, the onboard data recorder digitizes all of the various sensor feeds into one consolidated data stream. The software automates the process of uploading from the sensor's solid-state drive to the cloud. With the upload completed, automated post-processing algorithms can immediately start working on the data, turning it into actionable information. Nadir images are stitched together, producing an ortho photo that is used to colorize the LiDAR point cloud. LiDAR data can now be automatically analyzed to identify electrical poles, structures, and conductors. With these components located, vegetation can be identified, and the clearances can be accurately measured. Any vegetation falling outside of the utility's prescribed clearance specifications can be automatically identified and highlighted in a bright false color. Professional software tools remove much of the difficulty of juggling multiple images and data types, as it can group together the inspection assets to specific locations. The inspector is presented with a bundled set of data that relates to a particular asset within one customizable layout. To deliver the value from UAS operations, reports must be created. Reporting options that might commonly be delivered can be as basic as a PDF map with problem areas identified by GPS location, or a digital KML or shapefile that can be created from the same data. For other GIS-NIS integrations, a custom XML file can be specifically created for direct importation into almost any system. Across the United States, utility companies are already starting to benefit from utilizing unmanned aerial technology. With the potential of FAA beyond visual line of sight inspection operations beginning in just a few months, UAS technology will soon be more effective and less expensive than any legacy inspection method. This type of inspection work is almost certain to become the norm in the industry in just a few years.